Okay, welcome back. I'm going to show you now how to plot the efficient frontiers with three assets. In the last video that you can check, we did plot the efficient frontier for two assets thanks to the two-font separation theorem. This time, we're going to make things just one notch more complicated and add one asset. Okay, so you can already see in my spreadsheet what I've been doing for you. I've downloaded the last 10 years of data for three stocks, 3M, United Health, and Tesla. And I've already estimated their average return and standard deviation. So 3M has average returns of 0.142 or 14.2%, United Health 28.3%, and Tesla 44.5%. Standard deviation for 3M is 0.171 or 17.1%, 17.2% for United Health here. And Tesla is 55.3%, quite high. One thing that I do need, as you may remember, is the correlation. How do those stocks co-move with one another? How they're gonna move in relation with one another? So I have my correlation table that tells me how 3M moves with United Health here, how 3M moves with Tesla, and how Tesla moves with United Health. Essentially, three coefficients and good old risk-free rate that we will have to use for things such as the Sharpe ratio later on. Okay, so we're gonna get started and look for basically standard, basic, let's call it a basic portfolio of three stocks. That's something that we know how to do very easily. Just highlight this a little bit. Up. And, I'm going to have in the first row, weight 3M, weight on United Health or UH, and the weight on Tesla. Okay, we're going to start with like a very simple portfolio, maybe 0.4 on 3M, 0.4 or 40% on United Health. And on Tesla, well, I know that a portfolio by definition has a sum of weight that's 100% or 1. So the weight on Tesla is going to be 1 minus the weight on 3M minus the weight on United Health. Okay, 0.2. Now portfolio, I need to know a few things about my portfolio to make things interesting, to know if I'm actually going to invest in it. So I know to know a few statistics. The relevant statistics for a portfolio are the average return, the variance or risk, total risk here, and the standard deviation. Last, one thing that I'm going to use that's usually our benchmark when we talk about efficient frontier is the Sharpe ratio, right? That's all like a measure of performance or a trade-off between risk and return across my portfolios. Okay, so let's see what I can do here with this. So average return. So what's average return of a portfolio? Well, it's the weighted sum of returns of its constituents. So here the average return of my portfolio is going to be the weight of 3M times the return on 3M plus the weight on United Health times the return on United Health plus the weight on Tesla times the return on Tesla. Okay, so that's a good return of 25.9%. The variance, of course, it's the more complicated formula. If you don't remember it, I would recommend that you check your formula sheet. The variance of a portfolio is the sum, the weighted sum of the individual variances plus all the covariances between each pair of securities. So here it's going to be the sum of the weighted sum of individual variances of 3M, United Health, and Tesla. plus the covariances, so the covariance of 3M and United Health, 3M and Tesla, and United Health and Tesla. So we're going to have 3 individual terms and 3 cross terms. Okay, so let's get started with the individual variances. So it's going to be the weight square on 3M times the variance, which is the standard deviation square, plus the weight United Health square times the standard deviation square United Health plus the weight on Tesla square times the standard deviation of Tesla square. Okay. Are we done here? Well, not quite, because I still have to do all the cross terms. The cross terms are what? They're 2 times. If I want to think about the cross terms between 3M and United Health, well, it's the weight on 3M times the weight on United Health times the correlation between 3M and United Health times the standard deviation of 3M times the standard deviation on United Health. Okay, so that's lots of terms. We do this again for the co-movement, the cross term between 3M and Tesla, the weight on 3M times the weight on Tesla times the correlation between 3M and Tesla times the standard deviation 3M times the standard deviation on Tesla. And then what do we have left? Well, we have the correlation between United Health, the co-movement between United Health and Tesla, so that's 2 times weight on United Health times weight on Tesla times correlation between Tesla and United Health times standard deviation United Health times standard deviation Tesla. And I think that is it for now. Well, after all this hard work, standard deviation is simply the square root of the variance. So that gives us a standard deviation of 16.9% or close to 70. And last, what's the Sharpe ratio? Well, that's really something you're going to want to remember. The Sharpe ratio is simply the ratio of the average excess return, so average return minus the risk-free rate, divided by the standard deviation. So that's equal to the average return minus the risk-free return divided by the standard deviation here. Okay, and that gives us healthy Sharpe ratio of 1.4. Okay, so now I've basically, for nondescript portfolio of those 3 stocks, all the statistics I want to know. Now, how do I go from here to plot a nice bullet-shaped curve that's going to be our efficient frontier? Well, the good thing is I know something called the two-front separation theorem, and if I want to trace out the efficient frontier, I only need to find 2 portfolios on this frontier. What are 2 portfolios on this frontier? Well, there is one portfolio is the Minimum-Variance-Portfolio. Minimum-Variance-Portfolio. That's a portfolio, if you remember, that at the leftmost side of the bullet of my parabola. Okay, how do I find this portfolio? Well, it's the portfolio that minimizes variance. Not too bad. Okay, and then I have another portfolio that I know is, and that other portfolio is going to be the Mean-Variance-Efficient-Portfolio. How do I find the Mean-Variance-Efficient-Portfolio? Well, that is the portfolio that has the highest Sharpe ratio. As you will see, we also know this portfolio as the tangency portfolio. Okay, so let's just go and see how we can find these portfolios here. To find the minimum variance portfolio, what I'm going to do, I'm going to say that the minimum variance portfolio is the portfolio that minimizes the risk or the variance here. How do I find that? Well, I can actually use Solver and just go through all the portfolios of those 3 stocks that minimizes the variance. So I'm going to go under data in Excel, use solver, and basically set my objective as the variance, minimize that variance. How? Well, by moving the weights on 3M United Health, and then Tesla is going to adjust automatically because I've imposed that the sum of the weight have to be equal to 1. I'm going to uncheck that box so that I can allow shorting and variables to be negative, right? The weight can be negative. And then I simply click solve. Okay, let's look at my solution. So now I have a portfolio that's like 0.49, 49% on 3M, 46% on United Health, and only 3.7% on Tesla. And my risk has come down, right? My standard deviation, if you look here, is only 14.3. Okay, so I'm going to actually copy this down right here. And I'm going to also keep my statistics right here. Oops. Paste. I'm going to paste my values right here. And so I actually can keep everything. Okay, so I have my basically my first portfolio here. Okay, now I want to do the same thing and find what is the mean variance efficient portfolio. I'm going to go back. I'm going to say, what is the mean variance efficient portfolio? It's the portfolio that maximizes the Sharpe ratio right here. So I'm going to go back to data, solver. I'm going to now target an objective of the Sharpe ratio. That's cell N4. I'm going to maximize this still by changing F and G4, the weights on 3M and United Health. I'm going to solve this. All right, that's good. I have higher Sharpe ratio. Let me, still moving. All right, let's keep this. All right, let's copy this now down here. Let me try to copy this, paste values. Let's make this a bit prettier. So, okay, so now I have mean variance efficient portfolio, minimum variance portfolio. I have basically 2 portfolios on my curve. So I should be able to trace the efficient frontier, right? So what I need to trace the efficient frontier, I need to form a portfolio of the minimum variance portfolio here and the mean variance efficient portfolio. Okay, what do I need to do that? Well, I need to be able to estimate what's the return of a portfolio that is both invested in both of these assets. And what's the variance of a portfolio that's invested in both of these assets? Okay, so let's try to do this. Let's try to do this to fun. Efficient frontier from MVP and MVEP, right? Let's write that down so you actually know what I'm talking about. And this is the MVEP right here. Okay, so now things are easier. We're back to the case that we know. I can do weight on MVP, weight MVEP, and then return, the average return, variance, standard deviation. Okay, that's all I need. All right, so let's start with some simple weights. I guess I could do like 0.5. We'll change this in a minute. And this is going to be equal to 1 minus that. Okay? Right? So the sum of those weights are going to be equal to 1. For the average return, that's easy. That's the weight on the MVP times the weight on the average return of the times the average returns on the MVP. I'm going to fix this cell because we're going to move those later, and that's F12 plus the weight on the MVEP times the return here on the MVEP. Okay, and that's my average return. If I invest 50-50, 50% on the MVP, 50% on the MVEP, I have an average return of 25%, which is roughly exactly the average between this return and that return. Now the variance, well, I know that the variance is equal to what? The variance is equal to the weight of the MVP square times the variance. Let me here protect this cell so that it doesn't move around, times the variance of the MVP plus the weight on the MVEP times the variance on the times the variance on the MVEP. And again, I'm gonna put some dollar signs here because L, so it is protected. And then I have one more thing. I have the cross term, which is equal to 2 times the weights on the MVP times the weight on the other portfolio times the covariance. Okay, so right now that's something I do not have. I don't know what's the covariance between the MVP and the MVEP. So I'm just gonna put 0 here. We're gonna get back to that. That's maybe the one thing that we have left. And then standard deviation is going to be equal to the square root of my variance, other J19. Okay, great. So now we have one more thing to do before we can draw the efficient frontier, is that we have to find exactly what's the covariance. Okay, so covariance between the mean-variance-portfolio and the mean-variance-efficient-portfolio. And that actually takes a little bit of work. Okay, why? Well, because both of these are composed of 3 different assets, right? So the minimum variance portfolio is basically a portfolio of 3M, United Health, and Tesla. Same thing for the mean variance efficient portfolio. And so to estimate the covariance between those, I'm gonna have to do like a lot of cross product. Okay, so if you don't feel like following up with me, just fast forward this section. I'm just gonna go pretty slow, try to show you exactly how to get this covariance properly. Okay, so let's start. The first thing I have is I have like the identical cross terms, which are the weight, for example, on 3M times on one hand, times the weight on 3M in the other side, times the variance or standard deviation of 3M square. Okay, so that's the individual term plus the weight on United Health times the weight on United Health in the other one times the standard deviation on United Health square plus, and the same thing for Tesla, the weight on Tesla in the MVP times the weight on Tesla in the MVEP times the standard deviation on Tesla square. And then I have all the cross terms. Okay? So the first cross terms is the cross terms of 3M with United Health. How many cross terms I have between 3M and United Health? Well, I have the weight of 3M in the MVP times the weight of United Health in the MVEP plus the opposite, the weight in the first one times the weight of 3M. So the weight here, the first one, times the weight in 3M here. Okay? And this is going to be multiplied by what? By the covariance of 3m and united half, which is equal to the correlation of 3m and united half times the standard deviation of 3m times the standard deviation of united half. Okay, so that's a lot, but that's only one of them. I still have to do the cross term of 3m and Tesla, which is the weight of 3m in the first portfolio times the weight of Tesla in the second portfolio. So the weight of 3m in the first portfolio times the weight of Tesla in the second portfolio, plus the weight of Tesla in the first portfolio times the weight of 3m in the second portfolio times the correlation Tesla and 3m times the standard deviation of 3m times the standard deviation on Tesla. And then one last one, that's the cross terms between united half and Tesla, plus the weight Tesla in one times the weight united half in the other one times the correlation between Tesla and united half times the standard deviation united half times the standard deviation on Tesla. And let me have a look. Does that look like it is correct? Well, we better hope it is correct. That's the covariance. Okay. So now I'm gonna go back. Okay, so let's just kind of highlight this real quick. Let's put this in kind of red color. Just gonna stop it black. Bold. That's a bit dark. Oof. What am I doing? Okay, and then let's go back to our variance formula where I've left a 0 here, but that's not 0. So we said that's the weight on the MVP, 2 times the weight on the MVP, times the weight on the second on the MVP, times, we know that's equal to the covariance, which is equal to A17. Okay, I'm going to protect this cell right here. Okay, and so I think that we're almost done. So basically, we have everything we need. We have for every weight on MVP and MVP, we have the return and the variance. So what I'm gonna do now, I'm gonna basically try to go from maybe -3 to, let's do 2.5, and I'm gonna complete basically, nope, didn't work. Alright, so this is 1 minus that. Let's hopefully Excel is going to understand. Yep, here we are. So we have just a series of different portfolios here where I varied the weight, right? So you see that that's just a list of different portfolios where I varied the weight. And then I can extend my variance formula, my average return formula. You can see that the average return depends strongly alright, so that's not 1 minus. Right, so you see my average return depends strongly on the allocation. Okay, so something is obviously wrong here. Just fix this. Alright, this looks better. I can do the same for my variance and standard deviation. Okay, so I have a bunch of portfolios that are a mix of MVP and MVEP, and I'm pretty much ready to actually draw this, right? So what's the efficient frontier? It's simply a plot of Well, that was fast. It's a plot of standard deviation on the x-axis and average return on the y-axis. Okay, so let me select data here. I'm just going to erase this. Series 1, that's efficient frontier. X values are what? X values, well, X are standard deviation, as we said. Okay. And Y values, on the other hand, are average returns. Okay, seems to work. Okay, oh, and let's see. It gives us, oh, and here we are. So like this nice common bullet shape curve, also known as a parabola, which is the efficient frontier. So there you have your efficient frontier. Okay, so maybe we can do a few more things, plot more things on this efficient frontier, convince yourself that that's really the efficient frontier of 3 assets. So I'm gonna actually add some more assets. First thing we want to add is Tesla. We always want to add Tesla. What's the X value for Tesla? Well, that's the standard deviation for Tesla, right? So where's the standard deviation for Tesla? It's right here. And what's the Y? Well, that's the average return for Tesla. And that's it. So let's see, where is Tesla? Well, Tesla is far out there, but it is inside, right? We knew that. All right, let's now add 3M, United Health maybe. Start with 3M. X value for 3M, 171. And 142. Okay, where is 3M? Oh, it's right here. Oof, it's really close. Close but not on it. And last, select data. We are going to do United Health, right? X is going to be standard deviation, and Y is going to be United Health average returns. That's that. Okay, where is it? Oh, it's here, inside. Good. And the last thing I want to show you is that we're going to confirm that basically this is, we can actually plot the capital allocation on a capital market line, the line that goes from the risk-free rate to the tangent portfolio. So first I want to plot the risk-free. Oof, what happened there? Yeah, so this guy. Select data. Let's change this guy. Risk-free. Alright, so what's the X for risk-free? That's actually 0, right? And the Y is actually, let's just take it, 0.2, right here. Okay, that looks more like it. Here's the risk-free rate. So how do I plot the capital market line now? Well, I'm gonna go back to the drawing board and find a portfolio that's a combination of the MVEP and the risk-free rate. Okay, well, let's do this out here. Okay, capital allocation line, risk-free with MVEP. Okay, so weight on MVEP right here, weight risk-free here. Let's correct this typo. And let's move from maybe 0 here, 0.1, 3.5, that sounds good. And the weight on the risk-free is 1 minus this. Okay, and you see that when you go past 1, you're basically shorting the risk-free or borrowing. The return on the portfolio is equal to what? Well, it's equal to the weight on the MVEP times the return on the MVEP plus the weight on the risk-free times the return. Oops. The weight on the risk-free here times the return. That was like all the way here on the risk-free. What I want to do is I'm going to want to protect those values that are not going to move when I change the portfolio and put little dollar signs around them. Okay, so the return when you're all on the risk-free is equal to 0. Oh, what is that? No, that's not the right cell. Abort. That's the covariance. The right cell is this one. Okay. And you want to check that. You want to make sure that when the weight on the risk-free is equal to 1, you're exactly at 2%. Okay, so that's the return of this whole portfolio. Now let's look at the standard deviation. Well, let's do the variance first. The variance is equal to what? Well, that's the weight of the MVEP square times the total risk of the MVEP. Okay, that's, again, I'm going to protect this cell. Plus what? Well, plus 0, because the variance of the risk-free is 0, and then the covariance is also 0. Okay, so the variance is actually fairly simple, and the standard deviation is equal to, well, usual square root of my variance here. Okay, so I can just compute my variance, increasing as I increase the loadings on the MVEP and then the standard deviation. And now I'm ready to add capital market line to my market line, also tangency line, right, because it hits the tangency portfolio. X values are up. What am I doing? X values is going to be this thing, standard deviation. Y value is going to be returned. Okay, and there we have it. Maybe I've gone a little bit overboard here. Let me kill this. That's a bit crazy. All right, we can do more. We can lever 3 to 1, maybe 2.5 to 1 is more appropriate. There we go. Okay, and then you have your capital allocation line, which is tangent. Where is it tangent? Well, at the tangent portfolio or the MVEP by construction. Remember, where is your minimum variance portfolio? It's here. So basically what we did, we estimated those two portfolios, then figured out this curve by mixing those two, one being here, that's the minimum variance portfolio, the other being here, that's the Mean-Variance-Efficient-Portfolio. Okay, well, this is it. This is how you compute the efficient frontier, where you have more than 2 stocks. So going from 2 to 3 is kind of a conceptual gap, but going from 3 to 4, 4 to 5 is actually a lot easier once you have watched this video. All right, well, thanks for watching, and good luck plotting your own efficient frontier. Thank you.